Hey dudes, we're checking out 5.3 Simple Rules of Differentiation. It's simple. We're going to look at 3 out of 4 of them today, and this last one we're going to do in class sort of together. It's the bread and butter of calculus. So I want a little structure there, but let's try these 3 together. Differentiating a constant is sort of like saying that we have a function f of x, and it's not something fun or neat like x plus 2x plus 3 or 2x squared plus 3x. It's something kind of boring like 5, right? If we had this, what f prime of x means is it's a rule for the slope of this curve at any one specific point x, right? Well, that's what the derivative is. So if we had something more basic like f of x equals 5, we can still find the derivative of that. It's the slope, right? So here's a line. This is f of x equals 5. And it's just this horizontal line. And so if you pick any 2 points, like that point and that point, it has 0 rise but some run. I don't know, 4, right? Its slope is 0. So 1 point, oh, it's time to do some math. The point here would be 0, it would be 4, 0, right? And as you brought this closer, if you use 2, this would be between here and here. You'd rise 0 and run 2, and so you'd have a point here at 2 comma 0. Same thing here, right? And this would just make you a nice horizontal line at 0, which means the f of x is 0, right? The equation for this line is y equals 0 x plus 0, otherwise known as y equals 0. So the constant, the differentiated form of this is just 0. Same thing if we had, say, f of x equals -3, right? Well, here, let's use this derivative tracer. We're going to use this next time I see you, so let's try it out here. This helps us just find derivatives. Let's turn this off because that's annoying. Let's turn that off, and let's do this. We're going to put in different functions next time I see you and mess with them, but let's look at 5, y equals 5. Right, so there's the slope, and if we move this back and forth, we can see the different points that you get. Here's put in 4, and 0 is the derivative at that point, and so you get this horizontal line. Same thing if you end up with something like -3. There's our horizontal line at -3, and the slope is still 0. Y equals 0, right? That's the equation for the slope. You can see that the derivative of that should be 0 as well. Okay, let's keep going from there. We want to be able to add derivatives, right? So if our function is 2 things added together, right, 2 functions, if f of x is u of x plus v of x, f prime of x is u prime of x and v prime of x added up. It's called the addition rule. So I want to show that that works. And if you don't love the derivation, it's not a huge deal. But I just wanted to show you that that's the proof. This is our first principles definition of a derivative. It's the limit as we change the y values and divide by the change in the x, right? So we can do that same thing here. This is how u is changing the y value for u. This is the way v is changing, and you look at the difference between the changed values and the unchanged values and divide by how x changes. If you clean that up, it looks like this. If we distribute this in and clean this up a little bit, turns into this, and then we can move all of the pieces to one side or the other with the v's on one side and the u's on the other, and this really turns into this piece. This whole chunk is really just the derivative of the u's, and this chunk is the derivative of the v's. Long story short, this is what I want you to walk away with, right? If you're taking a function where there's two pieces added, you can just, to take the derivative, you can take the derivative of each piece and add it, right? Not too bad. It doesn't always work that nicely. And so here's the last part that we're going to look at, which is the product of a constant and a function. So here's our definition again. If we're trying to find some constant times the derivative of a function, what that might look like is this. This is sort of like saying the constant times one y value times minus the constant times the other y value, right? When we're talking about taking 2 points and bringing them closer and closer to each other. So here's 1 point, and this is the other point, right? And dividing by h, and h is the distance between those. You can factor out the c value, which is nice, and then the limit of all that mess times c is really just c times the limit of all that mess, and the limit of all that mess is just called the derivative, right? So this piece, this is just the derivative, which we call u prime. So in short, if you had like 2 f of x, right, and you wanted to take the derivative, you'd have 2 f prime of x, right? Not that big of a deal. Okay, so those are kind of 3 basics that we're going to look at. This 4th one is what we're going to look at in class. We're going to use sort of a structured format to figure out a faster way to differentiate. And we're also going to use this derivative tracer software that we were playing with here before. And I will see you then. Bye.